to asymmetric and symmetric object images in humans, the study of brain evoked potential. So let me start with giving you some basic concept behind my research. So as you know that perceptions is a general concept that refers to any manner in which a part of a pattern can be mapped onto another part. And as simple as you can easily conclude from these two pictures which one is a symmetry and which one is the violation of symmetry, or also known as asymmetry. It is because our perceptual mechanisms that allows us to extract the structural difference between these two pictures to see the structural difference between them, and came up with something that we call the perception of symmetry. But the question is, how does it work in the brain, or how does our brain interpret the visual information of an object, and came up with this perception of symmetry. To answer this question, this is the three-dimensional view of the human brain. Any visual information arrives into our eyes in the form of visible lights, and the eyes will focus the light into the photoreceptor cells in the retina that will turn it into the neural impulses that will go firstly to the lateral genital nucleus near the thalamus, and then goes to the back side of the brain to the area called the primary visual cortex. From this area, there are two streams involved. The first stream is called the ventral stream, that is mostly responsible for the object processing or object recognition. So in other words, trying to answer the question of what is the object. And the second stream is called dorsal stream, which is responsible to extract the information of the position of the object. So in other words, where is the object? Usually the preparation for the motions. But the problem is where and when the perception of symmetry occurs in the visual processing context, like I mentioned earlier, is largely unknown. So trying to approach this problem, so one of the ways is to measure the electrophysiological response of the human to specific stimulations that includes symmetry. One of the methods is using the EEG or electroencephalography, which is the recording of the electrical activity along the scalp produced by the wiring of the neurons within the brain. And one of the common methods is by using the non-invasive scalp electrodes like this, like we use in the experiment, that basically measure the potential difference between two electrodes like this. This is the example of raw EEG measured from one channel. To extract the brain evoked potential from the raw EEG, we usually use the stimulation. In this case, we use a visual stimulation like this in a time-locked manner during the recording of the raw EEG. And after that, we took some segments of the raw EEG, and then doing the average of operations for the segments within the same stimulus category. And then we have obtained the evoked potential, or brain evoked potential. So the objective of this research is to investigate human electrophysiological responses to either asymmetric and symmetric object category using the temporal and spatial analysis of DEP. So let me show you some methods involved in the experiments. We used 7 healthy and right-handed subjects aged between 22 and 34. As the stimuli, we used 5 grayscale pictures As you can see here, 5 pictures that involve some levels of symmetric combinations, such as flower, butterfly, face, bird, and car object. And we tried also to quantify the symmetry within the stimulus images using this formula. So basically, it works just like to compare, for example, to obtain the vertical symmetry, we compare pixels-wise the similarity between this side and these sides of the stimulus image. And of course, for the horizontal symmetry, we compare this side and this side to find the similarity, and then came up with the percentages of the horizontal symmetry. When it comes to the experimental design, we put the stimulus display at a 75 centimeter distance from the subject's eyes, and we asked subjects to look at the center of the screen, and also minimizing movement and eye blinks. And the image is shown one by one during 300 millisecond latency, and according to this time diagram, and we took 300 time sample randomly with the same probability. In the analysis stage, we concentrated on the 3 BEP components: P100, which is the first positive peaks after 100 milliseconds after onset, and the N170, the first negative peaks around 170 milliseconds after the stimulus onset, and on P300, 300 milliseconds after the stimulus onset. And let me show you some results from our experiment. This is the results of the symmetric quantification, the formula I showed you before. From this table, we can confirm that the flower has the highest has a quite high vertical and horizontal symmetry, and for the face, it has a face and butterfly has a vertical but low horizontal symmetry. The car and bird we consider as asymmetry. So according to the Malak et al. In 1995, we tend to find the response of which are the biggest for flower, and then that bigger than face or butterfly, and that also bigger for car and bird. And this is the BEP, the grand average BEP for P100 and O1 and O2, this and this. And this is the P300 recorded at PC. You can see the P300 component up here, and N170 at T5 and T6. You can see a biggest and distinct response of phase occurs in both hemispheres, and you can see that more clearly in the peaks analysis. You can see here very distinct for phase, as we usually call the phase sensitive, occurs in T5 and T6, which is also observed in many other studies. But the most important results in our experiment is the N170 mean latency. As you can see, the slope indicating that when the stimulus are more symmetric than the N170 tends to be faster than the asymmetry. It happens at the T5 and T6 of both hemispheres, and very stable across the subjects. So our results was congruent with many other studies. For example, from Cassie et al. In 2006, we came up with a conclusion that the N170 latency is the index of the symmetrical property. Also, this one I mentioned before. So let me conclude this presentation.